All right, so we did the Newton's second law math problem here, the word problem. And I want to do one more, but you'll notice I added something. I wrote up here that this was a horizontal scenario because our acceleration ended up being in the x component. Let's talk about a scenario where the net force and the acceleration, the unbalanced forces, I guess, are in the vertical component, the y component. So I'm going to slide this down a little bit so you can see. All right, but the scenario is an elevator car, which kind of makes sense because they move vertically. But an elevator car is being pulled up by a cable with a force of 5,200 newtons. What is the acceleration of the car if its mass is 500 kilograms? Now, I don't necessarily know if it is unbalanced with the forces, but I'm going to make an assumption if they ask me to solve for an acceleration, it probably is accelerating. Either way, we know that to start these types of problems, we don't do KU charts, we do FBDs. All right, but you really got to dig deep into what we learned at the beginning of this unit. The force that exists if you are on Earth is Fg. All right, now we don't know the value of that right now, but we're going to talk more about this because we're going to need this, okay? This can be a little bit misleading, but I didn't try to trick you with this problem. The cable, is pulling up. All right, and let's just assume that it is accelerating then up from maybe rest. All right, these problems can sometimes get tricky, but if it is accelerating up, we know that the total force, the net force, needs to be up as well. Now this is a cable, but it's the same idea as a string, so it's tension in that cable. All right. So the idea again is that, okay, they're asking me for an acceleration. If it is accelerating up, which I kind of hinted that it is in this, I know that I have an unbalanced force, total force, and that unbalance needs to be up, so Ft is larger than Fg. Long story short, if there is an acceleration from unbalanced forces, we need to set up Newton's second law. But here's the difference. This is occurring in the y component. So my forces then are the tension from the cable and also the weight of the cable car itself. Keep in mind, Fg is weight, not mass. They're two different things. Okay? All right, so Ft, I know that it's upwards with a force of 5,200 newtons, but Fg I don't know, okay? And so this is where we got to kind of stop and think real quick about something I taught you in the, I think it was our Hooke's Law lab, I think so, the pre-lab for that. I taught you that Fg can actually be solved for if you know the mass and you know the acceleration due to gravity of the planet you're on, which is Earth. So the good news is I know the mass of this cable car is 500 kilograms, and I know the acceleration due to gravity on Earth is negative 9.8 meters per second squared. So if I calculate this real quick, I get negative, because remember weight is always pulling objects down towards the Earth, I get negative 4,900 newtons. I'll give you a general rule, and no joke, I remember this from my physics teacher in high school, some simple things. For these force questions with Newton's law, if you're given the mass of the object, it's probably a good idea to just solve for the weight right away. All right, in the previous problem I showed you earlier, we didn't do it, but for this one, we're going to need it. All right, so if I plug that into my Newton's second law right here, keeping in mind it is negative, I've got negative 4,900 newtons. These are the forces acting on the cable car, and the cable car itself is the mass that's accelerating, so that's 500 kilograms. And now, once again, the only unknown is the acceleration that it has vertically. All right, when I add these up, this ends up being a positive 300 newtons. And this kind of confirms my assumptions over here that it was accelerating up because of an unbalanced upward force. The math will always correct you if you assume wrong, but of course in this we assumed right. So the total force on this whole car is upwards, which means it should then have an upwards acceleration. It should be positive as well. Again, with mass being scalared, if I take a positive total force divided by a scalar that does not have directions, I should, of course, then get a positive acceleration. Be mindful, again, this is in the y component. It is upward, so I'm going to put positive, and it is 0.6 meters per second squared. All right. So do be mindful, of course, that things can accelerate vertically as well. Elevators are great examples of this. But even besides that, if you think of projectile motion, we had acceleration caused by gravity in the y component. So there are a lot of scenarios where objects can accelerate vertically in the y component.